All right, we're going to start with the introduction to basic electronics. This will create a financially rewarding career in the high-tech industry. It's just the first step. And, well, let's get on with it here. All right, what I'm going to do is we're going to start with what I consider the modern history of electronics. I mean, I'm not going to go into every little detail. If you go on the internet and go to one of the search engines and say modern history of electronics or the history of electronics, you'll get something that's 100 times what I've put out there. This is just a brief introduction, just to give you a little bit of a background, how we got from the transmission of radio signals up to where we are now. All right. Then we're going to move on to some electronic basics and some basic electronic fundamentals. So let's start our journey here. All right, starting as a brief history of electronics, Mr. Marconi, first name Guglielmo, and again, I hope I'm pronouncing his first name correctly. He was one of the first, or was the first, to have the first successful communications across the Atlantic. He was very popular back then, and he started the ship to shore. If you look right there, you can see a very primitive or a very early transmitter and receiver. This was the equipment right here. You can't really see, but I believe that was the antenna right there. All right. I mean, it was rudimentary, but basically for its time, it was something. All right. Okay, John Ambrose Fleming. He was the one that developed or invented the first vacuum tube. They called it the Fleming valve. It was on the early 1900s. Right here it says 1904. Basically, it was a tube. It was in a glass. It was in a glass envelope, and it had an electrode and a heated filament and a plate. And basically, this allowed the flow of electrons in one direction. All right, and we'll see that now. Right there, the vacuum tube that he had back then was very similar to the silicon diode that we have today. All right, and so let's just move on here. Lee DeForest took Fleming's tube and he inserted what they called a grid, which would allow the tube to amplify electrical signals. All right. Prior to that, if we go back to this one here, on this receiver, if we were just using a two-element tube to listen to transmissions, we would have to have some type of headset that would be put on our ears, and then we could hear the different radio transmissions. But with the development of this triode, which was a three-element tube, okay, this allowed electrical signals to be amplified, and therefore we could have a speaker. Okay, the old radios with the speaker in front, a family could sit around the living room and listen together to transmissions. This was the beginning of probably entertainment radio. All right, then, you know, well, I shouldn't say that. If we look at tubes, we'll notice that the tubes are very bulky. They transmitted a lot of heat. So when we developed the first transistor, and they call it the bipolar junction transistor, it was basically developed by Bell Labs right here. What did that do for us? Well, it made things a lot smaller, all right, and we didn't have a heat problem as we did with tubes. if you notice, we can go back here. If you look at Fleming's receiver, all right, these were the tubes. I mean, they had to be exposed so we could dissipate heat, all right? If we go back to the transistors here, okay, I mean, they really didn't dissipate a lot of heat, and if they did, we could use some type of heat sink that could be placed upon these, and we could have them in an enclosed box. So the transistor was a great development in electronics. All right, and this led to what we know today as ICs, integrated circuits, or chips. And basically what we can do with a chip, and here is we can take a large electronic circuit and place it in this chip, and all we need to do is just take it, place it in a circuit with the associated support circuitry, and we've got it. I mean, what he's showing here is a CMOS chip, 4511, and if I remember correctly, that's some type of logic chip. But with an IC, integrated circuit, all right, we draw less current. We don't have a heating problem as we did previously with vacuum tubes or even with some large transistors, all right? And it just takes up a lot less space. It cuts down on labor, and it just led to the development of electronics, and it's really been an explosion with these things. So with the advent of the chip, we started to come out with some nomenclature here. SSI, MSI, okay, and you look at the previous slide. We talk about VLSI and LSI. Okay, when we talk about that, is how many different functional components that we can place on a silicon chip. So if you look here, okay, SSI stands for small scale integration, and if you look at the bottom here, it says up to 100 electronic components per chip. So I could take this IC, integrated circuit, IC stands for integrated circuit, and I could place up to 100 electronic components per chip. All right. Then the next step up, when we started to develop this, where we could, pardon the expression, stuff more things in a smaller space, we have MSI, medium scale integration. And there, if you look here, we could place between 100 and 3,000 chips, or 3,000 electronic components per chip. So basically, what we're doing here is we are putting more and more electronic components in a small standard area, which, think about it, the more things I can place in a small area, I can now just take this chip, this integrated circuit, and I can place it on a circuit board. I cut down on a lot of labor costs. Okay, the next part is up first. You know, in the previous slide we talked about SSI, MSI. Now we're talking about LSI, large-scale integration, and VLSI, very large-scale integration. Again, all we've done, or all what was developed, is it allowed us to put more components in a small area. For instance, if you look down here, it says LSI as well as VLSI in the 70s, 80s with tens of thousands of transistors on a single chip, later hundreds of thousands, then millions, and now billions. So zeroing on this statement here, all right, right now we have billions of components on a wafer, all right. Without this development, we would not have the personal computers, the smartphones, some of the electronic devices that we take for granted now. Cameras, all right, if you look at cameras, they're very small and very light. They draw very little current. If it wasn't for the development of this LSI, VLSI, or the development of the integrated circuit, we would not have any of these devices. All right. So this in itself was very, very important in the development of electronics today as we know it. And this is what I mean. All right. Now, basically the only thing I've done on this slide, I'm not even up to date on this. All right. This is the vacuum tube computer of the 60s, and here we have a computer of the 70s. All right. I mean, this one right here is antiquated now. I mean, compared to some of the I mean, look at the smartphones we have. Some of the smartphones have better graphics, faster computer power than this thing here. I mean, if you can see this, look at the graphics in there. I mean, this was wonderful on its day, but look at the graphics on your smartphone. All right. And again, right now, if you opened up a smartphone, you would see very, very small components. You would see a chip that probably has 100 times the computing power of this, and probably 10,000 the computing power of that. All right. So the miniaturization of the electronic field has led to the development of flat screen TVs, smartphones, personal computers, tablets, and so forth. I mean, this has really been a large and great development. Okay, right now we're gonna look at some of the things we talked about just to jog your memory. All right, and see if you can answer these. And again, we have the answers at the end here. So the first one, who was the name of the electronic pioneer that was the first to have the first successful communications across the Atlantic Ocean? John Fleming, William L. Marconi, Lee DeForest, or Dwight D. Eisenhower? So hit the pause button, see if you can remember who did that. Answers are coming up. All right. Well, here we go. Who do you think that was? Well, it was Marconi. It was this guy. All right. He's the one that did it. All right, next one. When manufacturing, the technology provides the fabrication process so that 100 to 3,000 electronic components can be inserted into an integrated circuit. Is that SSI, small scale integration, MSI, medium scale integration, VLSI, very large scale integration, or IC for integrated circuit? What do you think? Well, it's MSI, medium scale integration. All right. Next one. All right. Who was the name? Okay, here we go. I did it for you before. Who was the name of the electronic pioneer that was the first to have succeeded? Marconi, John Fleming, and medium scale integration. Those are the answers there. All righty. Okay, let's go on here. All right. If you'd like additional study materials Also, let me know how you like my presentation. You have my email through Udemy. Send me an email. I will try to have a little bit more study material on this. All right. And again, you have my phone number, which I put up at the very beginning. You can also call me. All right. Let's go on.